You know what bothered me for years in the shop? I would build something, a cabinet, a bench, a simple frame, and the joints were tight, the glue was good, everything looked right, but somewhere down the line, wood would split along a grain line I did not expect, or a curved piece I cut from a straight board would snap under stress, right where the grain ran out. I could not figure out what I was doing wrong. Then I started studying how the Vikings built their ships. And I mean, really studying it. Not the Hollywood version with horned helmets and battle axes, but the actual craft. How a handful of men in Scandinavia over 1,000 years ago could split a single oak log into planks so strong and flexible that they would cross the North Atlantic in an open boat. No plywood, no epoxy, no marine screws, just wood, iron, and a deep understanding of how a tree actually works. What I found changed the way I think about every board I pick up. Today, I am going to walk you through 15 foundational principles from Viking shipwright building that every woodworker should understand, whether you are building a boat or building a bookcase. And stick around to the end because I will show you a marking technique from the Norse tradition that is so simple and so effective. I cannot believe it is not taught in every shop class in the country. Let me show you what these craftsmen figured out. The Viking shipbuilding tradition, specifically the clinker-built or lapstrake method, is one of the most elegant and efficient woodworking systems ever developed. And what makes it relevant to you and me is that the core principles are not about boats. They are about understanding wood. Once you see how the Norse shipwrights thought about grain, structure, and flexibility, you start recognizing mistakes in your own work that you never even knew you were making. So let us start with who these craftsmen were and why their methods still hold up. When we talk about Viking shipwrights, we are talking about Scandinavian craftsmen working roughly from the 8th century through the 11th century, Norway, Sweden, Denmark, and the coastal regions around the North Sea and Baltic. These were not hobbyists. Boat building was central to their entire civilization. Trade, exploration, fishing, warfare, all of it depended on ships that could handle open ocean swells and still be light enough for a crew to drag overland between rivers. The ships we have found preserved in burial mounds, like the Oseberg ship and the Gokstad ship, are over 1,000 years old and still intact. The Gokstad ship is about 76 feet long and built from oak when researchers reconstructed a replica in 1893 and sailed it across the Atlantic. It handled beautifully. The hull flexed with the waves instead of fighting them. That is not an accident. That is engineering. But here is what struck me most. These shipwrights did not work from drawings. They did not have engineering degrees. What they had was a tradition passed down through generations, a deep understanding of how oak grows and how it behaves, and a set of principles that are so fundamentally sound that modern boat builders still use them today. The guiding idea behind all of it is simple. Do not force the wood into what you want. Find the wood that already wants to be what you need. That single idea runs through every one of the 15 methods I'm about to show you. The first thing I learned, and honestly the one that hit me hardest, is that Vikings almost never sawed their planks. They cleaved them. They took a straight grained oak log, sometimes 3 or 4 feet in diameter, and they split it using wedges and a maul, no saw at all. They would drive iron or wooden wedges along the length of the log and let the wood separate along its natural grain lines. The result was a plank where every single fiber ran continuously from one end to the other. When you saw a board at a mill, the blade cuts across grain lines no matter how careful you are. You end up with fibers that are severed partway through the board, and those severed fibers are weak points. They are where splits start. They are where the board fails under stress. A riven plank does not have that problem. Every fiber is intact from end to end. I tested this in my own shop with a piece of red oak. I rived a piece off a short log with a froe and mallet, and then I sawed a piece of similar dimension from the same log. The riven piece was noticeably stronger in a bending test. It flexed without breaking. The sawn piece snapped. Same tree, same diameter, completely different performance. Now, the Vikings did not just split the log any which way, they split it radially, like slicing a pie. They would start by halving the log, then quartering it, then splitting each quarter into thinner and thinner wedges, radiating out from the center. This meant each plank had the grain running roughly perpendicular to the face of the board, what we would call quarter-sawn orientation. If you have ever noticed how quarter-sawn white oak is more stable and more resistant to cupping than flat sawn, this is the same principle taken to its extreme. The Vikings understood that a radially split plank moves less, cups less, and holds its shape over years of being soaked in salt water and dried in the sun. And they figured this out without moisture meters or wood science textbooks. They just paid attention to what the wood was telling them. Once the planks were riven, they still needed to be shaped. And this is where the broadaxe comes in. The Vikings used a large, single-beveled axe, what we would call a hewing hatchet or broadaxe, to smooth and flatten the faces of the riven planks. They could take a rough split piece of oak and hew it down to a remarkably consistent thickness, often around 1 inch for hull planking on a mid-sized vessel. The surface left by a skilled broadaxe user is surprisingly clean. It is not sandpaper smooth, but the fibers are burnished and compressed rather than torn. That matters because a burnished surface sheds water better than a sawn surface. I tried hewing a piece of white oak with a broad hatchet last year, and after about an hour of practice, I started getting surfaces that honestly looked better than what comes off my planer. The tool marks had a rhythm to them that was almost decorative. More importantly, the wood felt different under my hand, harder, tighter. That is because the axe was compressing the surface fibers instead of cutting them. Now here is the method that completely changed how I think about curved pieces. The Vikings used what are called grown crooks. When they needed a curved structural piece, like a knee brace connecting the hull planking to the crossbeams, they did not cut a curve out of a straight board. They went into the forest and found a branch or a root that already had the curve they needed growing naturally in the tree. Think about that for a second. When you bandsaw a curve out of a straight board, the grain runs out at the edges of the curve. You get short grain, and short grain is fragile. It is the reason curved bracket feet crack, and the reason coopered doors fail at the joints. But a grown crook has continuous grain that follows the curve all the way through. The fibers are never cut short. The strength is extraordinary. I started looking for natural crooks in my firewood pile and in fallen trees on my property, and I have found pieces with curves that would be perfect for table leg brackets, shelf supports, and even rocking chair runners. It is free wood that is stronger than anything you could cut from a straight board. You just have to learn to see it. The fifth principle is the clinker planking method itself. Instead of butting planks edge to edge like a flat panel, the Viking shipwrights overlapped each plank over the one below it, like clapboard siding on a house. Each plank, called a strake, overlaps the previous one by about 1 to 1.5 inches. This overlap does several things at once. It adds structural rigidity because the hull becomes a series of interlocking steps rather than a flat sheet. It creates natural channels that help shed water, and it allows the builder to create complex curves in the hull shape by adjusting the angle of each overlap as the planking rises from the keel. When I first saw a clinker-built hull up close, I was struck by how light it was for its strength. The planking on a Viking ship is thinner than you would ever dare to use on a flat panel hull, sometimes as thin as 3/4 of an inch, but the overlapping structure makes it incredibly rigid. Now, those overlapping planks need to be fastened together, and this is where the iron rivet and rove system comes in. A Viking rivet is basically an iron nail with a flat head. You drive it through both overlapping planks from the outside. On the inside, a second person places a small square iron washer, called a rove, over the point of the nail and drives it down snug against the inner plank. Then you cut the nail close to the rove and pin it over with a hammer, mushrooming the end so it cannot pull back through. The result is a fastener that pulls the two planks tight together, but still allows a tiny amount of flex between them. This is crucial. It is not like a modern wood screw that locks everything rigid. The rivet lets the joint breathe. It lets the wood swell and shrink with moisture, changes without cracking. Every time I put a screw into a panel joint now, I think about how much more forgiving a rivet and rove would be. This brings us to something that took me a while to appreciate. The whole point of clinker construction is that the hull flexes. It is designed to move. A Viking longship in open ocean does not slam into waves like a rigid fiberglass hull. It rides over them. The overlapping planks slide against each other just slightly. The rivets allow a tiny amount of give, and the entire structure absorbs wave energy, like a living thing. Modern wooden boat builders call this a monocoque structure, where the skin of the vessel carries the structural load rather than an internal frame. The Vikings figured out that a flexible skin is stronger than a rigid one when you're dealing with dynamic forces. And that principle applies to woodworking on land too. A table that allows for seasonal wood movement will outlast one that fights it. By the way, if you are enjoying learning about these shipwright methods, I put together something I think you will really appreciate. It is called Secrets of the Shipyard, and it covers 16 chapters of Viking and naval carpentry techniques that most woodworkers have never seen. 150 pages of real hands-on knowledge. You can grab your copy by scanning the QR code on screen, or just use the first link in the description. All right, let us keep going. The keel is where every Viking ship starts. It is a single massive timber, usually oak, running the entire length of the vessel. The Gokstad ship's keel is carved from one piece of oak nearly 58 feet long. Finding a tree straight enough and long enough for that is a task in itself. The keel has a T-shaped cross-section with a flat bottom and a vertical fin that the garboard planks attach to. Everything else in the ship references off the keel. If the keel is not straight and true, nothing else will be either. It is the same principle as a reference edge on a board. Get that right, and everything downstream falls into place. The garboard planks are the first strakes attached to either side of the keel, and they are the most critical planks on the entire ship. They have to transition from the flat, horizontal plane of the keel to the curved, rising shape of the hull, which means they carry enormous stress. Viking shipwrights shaped the garboard planks with a pronounced twist along their length, sometimes as much as 15 to 20 degrees of twist over 8 or 10 feet. They achieved this partly through careful axe work and partly through steaming or soaking the wood in water to make it pliable enough to accept the twist. If you get the garboards wrong, the entire hull shape is compromised. It taught me something valuable about my own work. The first joint, the first reference, the first critical piece in any project deserves the most time and attention, not the least. When the Vikings needed planks to bend into curves that were tighter than the wood would naturally accept, they used hot water or steam to soften the fibers. There is evidence from archaeological sites of long troughs used to soak planks before bending. They would heat water with fire-heated stones dropped into the trough. Once the wood was saturated and hot, it became remarkably flexible. They would clamp it into position on the hull and let it dry and set into the new shape. This is the same steam bending principle we use today, but without a steam box, just hot water, patience, and an understanding that oak becomes cooperative when it is warm and wet. The Vikings sealed their hull seams with a caulking material made from animal hair, usually wool or cattle hair, soaked in pine tar. They would twist the hair into thin cords and press it into the gaps between the overlapping planks before driving the rivets home. The pine tar made the caulking waterproof and resistant to rot. It also stayed flexible, which is important because the hull is moving and breathing constantly. Modern caulking compounds are more convenient, but that combination of natural fiber and pine tar is still used by traditional boat builders in Scandinavia today. It works because it moves with the wood instead of cracking and falling out. Here is something that amazed me. Viking shipwrights built symmetrical hulls without rulers, tape measures, or printed plans. They used string lines stretched from the keel to temporary posts at the bow and stern, and they judged symmetry by eye. An experienced shipwright could look down the length of a hull from the bow and tell you if one side was a quarter-inch off. They used simple proportional relationships, like making the beam width a certain fraction of the overall length, and they adjusted by feel and experience rather than calculation. It humbled me. I rely on my combination square and tape measure for everything, and these men were building seaworthy vessels by eye. This connects to how they chose their trees. Viking shipwrights did not just want oak, they wanted specific oaks, straight-grained trees for planking, trees with natural curves at the root, flare for knees, trees with long, sweeping branches for stems and stern posts. They walked the forest the way a furniture maker walks a lumberyard, except they were reading living trees, imagining how each one would split, where the grain would run, what shapes were hiding inside the trunk. Choosing your material before you ever pick up a tool is the first and most important step in their process, and it is the step most of us rush through. The Vikings worked their wood green, meaning freshly felled and still full of moisture. Green oak is dramatically easier to cleave, hew, and shape than dried oak. The fibers are soft and pliable. The axe cuts cleaner. The wood bends more willingly. They did not kiln dry their timber. They shaped it green and let it season in place on the hull. As it dried, the joints tightened, the planks stiffened, and the whole structure became stronger. I have started experimenting with green woodworking in my own shop, using freshly cut oak for chair legs and rungs, and the difference in how the wood works is night and day. It is like cutting butter compared to hacking at concrete. The last principle, and maybe the most important one, is that Viking shipwrights built without formal plans. There were no blueprints, no cut lists, no exploded diagrams. The master shipwright carried the design in his head, based on decades of experience and an inherited tradition of proportional relationships. He built plank by plank, adjusting as he went, letting the wood tell him what it wanted to do. Each plank was fitted to the one below it, and the shape of the hull emerged organically from the process. This sounds reckless to modern ears, but it produced some of the finest wooden vessels ever built. The lesson I take from it is that sometimes we overplan and underobserve. Sometimes the best move is to trust your hands, trust your eye, and let the project tell you what it needs next. Let me share some patterns I have noticed over the years, things I used to do myself that the Viking tradition handles completely differently. The first pattern is reaching for the saw by default. Most of us take every log to a mill or rip it on a table saw without a second thought. But every saw cut severs grain fibers. The Vikings understood that riving preserves what the tree spent decades building. You do not have to rive every board, but for structural pieces where strength matters, consider splitting instead of sawing. The second pattern is cutting curves from straight stock. I did this for years. Need a bracket? Bandsaw it from a 2x10, but that guarantees short grain at the curves. The Viking approach of finding grown crooks eliminates that weakness entirely. Start looking at fallen branches and root flares differently. The third pattern is over-constraining joints. We glue, screw, and clamp everything rigid, and then wonder why wood cracks when the seasons change. The rivet and rove system allows controlled flex. Anytime you can design a joint that permits seasonal movement, you are working with the wood instead of against it. The fourth pattern is always working with kiln-dried lumber. Dry wood is stable, yes, but it is also hard and brittle and fights every tool you own. The Vikings worked green and let the wood dry in place. For certain projects, especially those involving bending or carving, green wood is vastly easier to work and often produces a stronger result. The good news is, once you see these patterns for what they are, you can start shifting your approach one project at a time. Now, for that bonus tip I promised at the beginning, this comes from traditional Scandinavian boat builders who still practice the old methods, and it is a marking technique for transferring plank shapes that I have never seen in any modern woodworking book. When a Viking shipwright needed to fit a new plank to the curved edge of the one already on the hull, he did not use a tape measure or a template. He used a simple compass, a pair of dividers with two pointed legs. One leg traced the curved edge, while the other leg scribed that exact curve onto the new plank. The distance between the legs did not matter as long as it stayed consistent. The scribed line was a perfect parallel copy of the existing edge. I started using this technique for fitting shelves into irregular walls, for scribing cabinet faces to uneven floors, and for fitting table aprons to legs that are not perfectly square. A cheap pair of dividers and this one technique will solve fitting problems that used to take me 3 or 4 attempts with a tape measure and trial and error. Before you head out, I want to make sure you know about my book, Secrets of the Shipyard. It goes way deeper than any single video can, with 16 chapters of Viking and naval carpentry techniques, 25 hand-drawn illustrations, and 150 pages of real hands-on knowledge. If you want to bring these old shipwright methods into your own shop, this is the guide to do it. Just scan the QR code on screen or click the link in the description to get your copy. Thanks for spending time with me today, and if you have not already, hit that subscribe button so you do not miss the next one.